After 41 years, an Indian is set to fly to space. Now, if everything goes well, and more importantly, if the weather is good, in just about a few hours, Indian Air Force Group Captain Shubhanshu Shukla will be flying to space to the International Space Station on board the Axiom-4 mission. And as part of our continuous coverage of the Axiom-4 mission, we have with us today Professor Aloke Kumar. He is a professor at the Indian Institute of Science in Bangalore. He has done extensive work on microgravity experiments and space habitation. But he is also a very close friend and the mentor of Group Captain Shukla, who I'm not sure if everybody knows this, was till very recently, till he flew to the US for the Axiom-4 mission, was doing his master's at the Indian Institute of Science, and Professor Kumar was his mentor during that entire tenure. So we have with us Professor Kumar, and welcome, sir, and thank you for speaking with us. We have a lot of questions about your camaraderie with Shuks, as you call him, and which is also his call sign, and the larger implications of this particular mission and how this is going to help us. So I'm going to jump right into the question. And of course, the first few questions are going to be about, you know, your personal interaction with Shuks. And I was talking to a few professors at IISc, and anybody who knows you and Shuks call you the Jay and Viru of IISc. So if you could just start off with, you know, when did you meet Group Captain Shukla, and how was your personal interaction with him?
Sure. So first of all, thanks for inviting me, Soumya. It's a pleasure always to talk to you. Uh, so my, I guess we first met once these astronauts sort of came back from Russia. After that, there was an Indian component of their training, uh, of which a particular part of the Indian component was handled by the IISc. There were other institutes handling other parts. IISc took part in some of the academic training part post their Russia training, and that's where we sort of first met because we were one of the I was one of the few professors who were enlisted to help train them. Um, and during our very first few conversations, we realized that there's a lot of things in common. We both enjoyed astronomy, and we both liked watching the stars under the dark skies, and that sort, I guess, sort of brought us together quite a lot because during that time, right after, it was right around the COVID times, and the air pollution was very low in our cities. So we could get a really good view of the stars from even Bangalore skies and other places of India. So which otherwise are always so light polluted, right? So we spent a lot of time fixing our telescopes, trying to see different type of stars, constellations, nebulae under the together, and I think that also brought us together because we share a lot of this common. Uh, uh, I said, a sense of inquiry towards what humans, what is out there in space, what should humans do, what should be the aspirations of the human civilization towards space. So I guess we have some things in common which sort of brought us together. Obviously, after that, he also enlisted here as for his masters, and then he started working with me for his master's thesis, which still is incomplete. So when he comes back, I hope he's going to come and finish it. So I'm going to not let him off the hook there. But yeah, so that's more or less it. It was basically just a sense of boyish wonderment at the skies, I'd say.
Professor Kumar, you just mentioned that, that Shuks was doing his thesis, and, you were his mentor. Because I think his thesis is also an extension of a lot of the work you have done on, space habitation and just generally different aspects of space habitation. Could you tell us a little bit about his work, your work, the general work that's happening in your lab
Yeah.
around space habitation?
Sure. So, I mean, I came back to India in 2017 from Canada. Once I came back, we started working with ISRO and on looking at space habitation. And one of the questions of my interest was, if we do send up start a moon base at some point of time, what are the technologies we need? How do you even start to think of something that bizarre? At 2017, when I was still talking to scientists and professors here, the idea of a moon base was still, a bit outlandish. It still is in some sense, probably even today, but it was quite outlandish at that particular time. Uh, and There was very little thought given as to how do you approach this from a technology perspective, what is realistic, what is not realistic. So we started looking at that particular problem, and we realized that if you do go to space, if you do set up a moon base, will require uh, maybe I'll just quickly step back a little bit. Once humans moved from Africa from one location to the other, they humans are a very local people. So we at every place where we set up camp, like be it Mohenjo-daro, Harappa, be it the cities of China, or be it South America, we learned how to adapt to the local environment. We became local people. We exploited the local resources, or we came to terms with the local resources, and we wanted to make use of what is available to us most, or in our own vicinity. Obviously, later on, we also develop trade, but we are still local people to some extent. Today, when we build a house in Bangalore, we typically source most of the material from in and around us, right? You are not going to source materials from Kabul if you have to build a house in Bangalore. So in some sense, we remain a local people. So if humans do end up going to moon for a moon base, they would learn to have to become local. They would have to learn how to exploit or understand what are the local resources, what are the things they can make use of, and how can they make a civilization out of that. So we started looking into that particular problem. We realized that one of the most abundant resources available on the moon is the local regolith, which is, in simple terms, regolith, the lunar regolith is the gravelly sandy material that is there on the moon surface. So it's basically it's a type of a white sand. So how do you use that white sand? I mean, sand is not a very useful material all the time. So how do you make use of that? We got started with that. We started making things like moon bricks out of moon sands, uh, and now our research is going progressing more and more towards that. Now we started off with space bricks. Now we are thinking of, okay, if we have to make a small colony for, like, say, 2 people or 3 people or 4 people, then what will the structures look like? How do you provide the astronauts enough security from, the harsh thermal conditions, the atmospheric radiation, the fact that there is no air there, all that. So we are thinking along those lines. So we are going on developing more and more technologies along that. So Shubhanshu's work is very closely intertwined with that. When Shubhanshu came and started working with us, uh, he uh, he started looking into this Martian soil problem, and seeing how the fact that on the Martian soil there are a lot of chemicals that are, not very nice in some sense. It has some sulfur content. It has perchlorate, which can be poisonous. So if you have to deal with that kind of Martian regolith, how do you deal with that? And how do you even conceive of a small structure in and around that? So that's what his work is more or less uh, around.
Professor Kumar, for India, this is a very momentous mission because at least 7 of our research institutes, including IISc, is going to be sending experiments which Shubhanshu would be, leading in microgravity conditions. As an expert yourself, who's also doing a lot of research on microgravity, various aspects of microgravity experiments, how significant is Axiom 4 going to be for India in understanding? Because we've not been able to do such an experiment, such a mission ourselves. Of course, Gaganyaan is lined up. But if you could tell us a little bit about the significance of Axiom 4 for India specifically.
Sure, sure. So, see, this is the thing I love most about this particular mission. Shubhanshu is not really going by himself. He's actually taking along with him our institutes, the work of our professors, the work of our students, all the hard work that they have put. So, in a sense, he's taking all of us out there. And this is the big thing about the one important point of a human mission, which is different from, let's say, a Chandrayaan mission or something, where people like others also get to actively participate. So there are many of these different experiments which are probably which are happening for the first time from India in microgravity. There are two experiments going from IISc. Uh, there are some experiments from some of my friends who I wish all the best. For example, Arvind Ramanathan from the INSTEM, he is looking at the effect of metabolic supplements on muscle regeneration under microgravity. So he's going to send these muscle cells and is going to look at how do stem cells, for example, sense microgravity. So he's been doing a fantastic work in his lab, and now he's going to send. I believe he's already there in US right now, working with the Axiom team on putting this experiment together. So basically, I think they will hand some of the researchers are in the US going to hand these experiments over to Axiom themselves. So these will be very, very important because till now India has no data on these issues. So we have the whole problem of space is an unforgiving environment, but we know we now understand quite a bit from a machine perspective. So if you have to send a satellite, what are the conditions we have to take care of, but India still lacks the data, own data about what is the effect of space on biology, uh, which could be by the humans, it could be proxies for humans and all other type of things. And this, I think, is a very, very important point for India to proceed it towards, because this is a very important area of research that is required if we ever have to have our own human space program. So I think for example, Arvind's work is going to look into how astronauts experience muscle dysfunction in space flight. So it's going to look at the effect of this muscle cells and how they change under microgravity. Then there is one experiment from another friend of mine, Sandeep Eshwarappa from IISc. He's looking at the survival and reproduction of this an organism called a tardigrade. It's a very small organism. Usually, there are plenty that grow in IISc also. I believe some of them he has isolated from IISc. You can find it around small ponds on moss and things like that. These are extremely tiny. You have to look under a microscope to see them. And they're also called water bears. They are famous because apparently they can, you know, the extreme environments of space are not so extreme for them. It's been shown that they can survive the very harsh thermal changes. They can survive even in vacuum. So for example, he's looking at what is going to be the effect of vacuum on some of these tardigrades, what is going to be the effect of, let's say, very low temperatures, radiation. These are things that he's already been looking at while at IISc. So he's going to do a comparative assessment of these physiochemical and morphological changes that are going to happen due to microgravity for these water bears. And we never know. These water bears will probably go to more places in space than humans do, given the fact that they can tolerate all these extreme environments. So these are some experiments. Another experiment comes from another friend again, Ravi Kumar Hosmani from University of Agricultural Sciences, Harvard. So there are all these brilliant experiments which I think are going to be extremely important with respect to collecting data on for our own space program, human space program. So I'm really glad that quite. I mean, I've just mentioned a few. I think there are about 7 experiments going in total. So these are going to be extremely important and contribute to our database of uh, microgravity conditions and human interactions in microgravity conditions.
So would we? I know it's too close to Gaganyaan. I mean, Axiom has happened too close to Gaganyaan. We are almost in the last leg. But will we be able to benefit in our own human space flight when Gaganyaan happens? From Shub's experience at the ISS.
I'm quite sure we will be able to. I mean, Gaganyaan is progressing, I guess, very well. Hopefully, we'll see more and more missions in the coming days from the ISRO on the Gaganyaan. We still have G1, I believe the first uncrewed mission is there. There's a second one, and I think there might be a third one, if I'm not mistaken. So we have a few uncrewed missions before we send the crewed mission. So we do have some time between the Axiom mission and our crewed Gaganyaan mission to happen. Uh, one of the things is obviously ISRO is doing everything it can. It's putting all its decades and decades of work to the test here, designing our Gaganyaan program and doing the engineering around it. It's hopefully planning for all the knowns and some of the unknowns as well. But space is a very unforgiving environment. I mean, we know that just a few days ago, I believe a Japanese spacecraft, the Japanese are just so great at engineering, and they failed a second time. The Japanese company failed a second time at landing something on the moon, landing a rover on the moon. So it shows that space is such an unforgiving environment that you really there are so it really is a place of most unknown unknowns, that even after engineering, over engineering and testing and doing everything you can still fail, and that's one of the reasons it's probably called the final frontier. It's a very, very challenging environment. So there are going to be a lot of unknown unknowns, which are difficult to anticipate. And given the fact that we have not had a human space program before, uh, this Shubhanshu's experience in space will probably tell us about what are some of these things that maybe he did not anticipate, maybe the mission also did not anticipate, and maybe how did the rest of the crew work around it. We'll get to know a little bit of the history of the International Space Station, of how the other astronauts, have fared in the past. Obviously, some of us, for example, we saw Sunita Williams and her, long stay at the International Space Station. We all prayed for her comeback and everything. But again, that also shows that the International Space Station, despite being such a decades-old technology, there's always room for mistake, and it is such an unforgiving atmosphere, an environment that the best of the best can fail. So this is space is something that makes the best of us a bit humble. So I think we'll probably learn a lot.
So I just want to understand that Axiom 4 mission came quite suddenly for Group Captain Shukla, because he was preparing for Gaganyaan and this mission came around and he was the chosen one from India. Any concerns that he shared with you? Because you prepare for a mission in 2027, but this happens to you. And did you get talking with him while he was training in the US? If you could just share a few conversations with him.
Yeah, I mean, I don't think he ever got concerned. He was always like, the day he got that final offer, he called me and he said, "I have a great news to tell you." And I almost guessed, and I was in my heart, I still had to wait for him to tell me what the news was. And uh, he was very excited at that time, and he was most excited about the fact that uh, he will interact with so many different institutions. NASA, I think, believe they had a interaction with ESA and JAXA, and this one single mission is going to give our astronauts such a big experience with all the leading space agencies of the world, look at their facilities, understand what's going on in the rest of the world, and train. I think he was very excited. He remains very excited now. The mission has gotten postponed a couple of days here and there, but I think he's enjoyed mostly interacting with all these different institutions, and I think there's a lot of new learning that he'll bring back home. He's also excited to take all these Indian experiments with him, and I think that's one of the big motivations for him, is that I'm not going alone. I'm, in a sense, I'm the only Indian going, but I'm carrying the work of so many other Indians, and he was very happy when it took quite a while, I guess, for all these experiments. They have to be space certified, so there's always an uncertainty till the last moment, till all the tests and everything come through, that whether these experiments will make it or not make it. So when he got to know that the experiments are going, he was quite happy. that he's going to carry with him the aspirations of the rest of the country.
Now, from an expert perspective, Professor Kumar, like, a lot of work from your lab, from a lot of labs in India, are now focusing on the India space program. So, as an expert in the domain, and also as somebody who is, I mean, it was a generation of the first scientists who are sort of going to put these experiments in space. How do you see India's focus on say space technology, space experiments? How do you see this field growing in the next decade or so?
So interestingly, I mean, despite the fact that Gaganyaan hasn't happened yet, there has been a slow, undercurrent of researchers already preparing for it, and I'm really glad. I've met many of them, and some of them are really great researchers. For example, Dr. Srija Lakshmi at IISc, she's also sending an experiment on board this Axiom-4 mission on looking at this crop yield for food crop seeds. Okay, so in microgravity. So India has always been a place where many of us have thought ahead, and it's sort of reflecting that there's already, despite the fact that Gaganyaan is yet to happen and the experiments on Gaganyaan are yet to happen, there are already people doing experiments towards this. And it's only because of that that when the Axiom mission came through, that all these different experiments sort of get going, because Axiom came in a very, very short notice, and research and science labs don't work at that fast a pace. So the reality is that all these people like Srija, Ravi Kumar Hosmani, and Arvind, Sandeep Ishwarappa, and all the others that not everybody's names I know. They have been preparing all along, and what is going to happen is the moment their experiments come back, the moment we start to have some results from that, I think there will be a very, very important quantum change in the way, because a lot of these people, me included, I last month, me and Professor Saptarshi Pasu, we went on a French microgravity flight, doing some fluid mechanical experiments. So it's till this year, to 2025, India had done very few experiments. In 2025, there's a quantum change. Our experiments we did with France, microgravity, these guys are doing all these experiments. And when the scientific community sees that, I think there is going to be a very big interest, and a lot of the youngsters who are coming in, the new assistant professors or the new postdocs, are going to want to do experiments. That's what I think. I can see some of that already, but I think after these experiments come back, after there is a solid scientific case made out for all these, there will be a even bigger leap towards this. So basically, what is going to happen is, this is, I think, you haven't asked me that question, but I think I just sort of want to point this out. This is one of the things about a human space mission, is that despite the fact that we send only a couple of our people to space, it is actually a much more inclusive mission compared to any other non-human mission, because it carries with them the aspirations of so many others, and it brings back extra hope and renewed direction for so many, and so many others get to participate. So I'm really looking forward to all these experiments coming back, seeing what the results are. Some of them hopefully will get published in our scientific journals, and that will lead to a even more excited outlook for microgravity science.
Professor Kumar, my last question, and it's going to be a cliched one because I know that you're already in touch with Shuks. But what is your message to him? Like I mean, before the mission, anything that you want to say to him on behalf of everybody who are waiting with bated breath to see, Group Captain Shukla fly to space with, like you said, all of our aspirations. Your final words, your message to Shuks.
Um, I think the most important mission is the most important words I'd like to tell him is, be in the moment, enjoy all the time you are getting in space, enjoy every single moment of it, do the things, every given free time you have, do the things that you've always wanted to do. You've been reading about so many of this for so many years. Now you actually get to do those. Just be in the moment and enjoy it. So that's my only advice to him.
Thank you so much, Professor Kumar, for joining us. And thank you so much to the viewers for tuning into this interview. A few months ago, we did an extensive tour of Professor Kumar's labs, and I will link that story and the video to our description. Please do check it out because there's some groundbreaking research that's happening from his lab at IISc. So please do check it out. Thank you, Professor Kumar, again, and thanks to our viewers. And please also follow our coverage of the Axiom-4 mission. We will do extensive coverage of the launch, the entire 14 days of Group Captain Shukla and his colleagues at the ISS, and also the landing and his safe return home. Thank you so much.